Hi, this video will present TabgenQA, a platform to generate non-relational, multi-tabular, numerical question answering benchmarks and evaluate large language models on them. Tabular question answering performance degrades with hierarchical headers, inconsistent units, and schemas, as well as when reasoning on multiple tables and multiple domains. Public leaderboards rarely reflect these scenarios. What if we could create a platform that generates table question answering benchmarks from scratch, specifying only the target domain, the perturbations to apply, and the number of tables, and let the user edit and validate the generated data, train and test LLMs to see which one works the best? In the first scenario, we tackle model procurement, namely the generation of benchmarks and LLM testing. Consider an ESG analyst who wants to understand which LLMs are the best for question answering on environmental disclosures. The analyst can log into TabgenQA, select the correct domain or use a custom one, indicate the numerical aggregation to perform, the number of samples to generate, and decide whether to create parallel or sequential questions. Finally, the user specifies whether to apply one specific perturbation or all of them randomly and, with just one click, generate the benchmark. After benchmark creation, the analyst can inspect the generated instances. By going into the History tab, the analyst can select one instance, edit its question, its answer, and the generated tables. For example, the user might want to change some values inside the table, or at the same time, switch on the second table, inspect it, and decide whether to add or remove rows, columns, or tables. Eventually, the analyst can evaluate different LLMs on the generated data. TabgenQA supports the OpenAI, Claude, and Gemini APIs, as well as Hugging Face models for local deployment. At the end of the evaluation, the user can go into the Leaderboard tab, filter the runs on the benchmark just created, and compare the model's performance on the same data. In the second scenario, we tackle failure diagnosis, where an analyst tries to understand why a model fails. From the Leaderboard tab, the analyst can click on one model run and inspect the predictions made by the model. In particular, the analyst can easily inspect the wrong predictions by analyzing the generated chain of thought reasoning trace. From there, the user might suspect that the failure is due to hierarchical headers, so the analyst goes back into the Generate tab, selects only the suspected perturbation, and generates a new benchmark to analyze model robustness on that perturbation. The third scenario is benchmark curation, where the analyst may want to obtain the data for further model fine-tuning. From the leaderboard, the analyst can click on one model inference run, click on the download button on the upper right, and obtain the full dataset composed by instances predicted correctly by the model, as well as their reasoning traces. This data can be used to fine-tune neural models and improve their question answering performance. We invite you to check our GitHub to explore TabgenQA further.